really good about the top stuff, but not so good about the...
Enough time.
Are you there? Hello? Oh.
Have you done it, Amanda?
Yes, I did.
Nice.
About it.
I felt good until the last 3 questions.
Yeah.
Are they hard?
Yeah.
I'm still struggling with knowing how to set them up, so I really need to go back through the online text and go through each thing, I think, because I'm still fuzzy. Right when I think I get it, then I don't have it. So are we recording? It has that little orange box. We're recording, right? Okay.
Yes.
All right, so do you want to just start running through some of these questions?
Sure.
Okay, question number 2, given a 90% confidence interval for mean heart rate, which of the following is the best interpretation of this confidence interval? I put B. We are 90% confident that the true mean heart rate is between 45 and 105.
Okay.
Is that what you guys got?
You put B?
Mm-hmm.
Okay. Yeah, that's what I got too.
Okay.
That sounds right to me. I haven't done it yet though, so.
All right. Number 3, the researchers decided, so it has the information, the University of Mississippi, testing the reaction time between males and females. 20 females, 15 males. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples to see if they are approximately normal. Are the requirements for a confidence interval satisfied? I put C, yes, because the QQ plot showed that it's normal distribution
Okay.
of the sample means, right?
Yeah, that's what I got too.
Number 4, I'm unsure of. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? What do you guys think?
Can't remember what the question was. I think it's independent.
Independent?
C. That's what I think.
Okay. Okay.
Yeah, it sounds like it'd be independent because they're just random males and females, not like couples or anything.
And do we know the standard deviation? No, we don't know the standard deviation. Wait. Do you think C? Did you submit yours, Mandy?
I just did on the online book. It has the same questions. I just went through those.
Oh, yeah.
Yeah.
That's right.
So I don't know if I have them right or wrong yet.
Okay. All right, question 5. A researcher is interested in estimating the savings account balance of customers at a large bank. Let's see. So the simple random sample is 30 customers. She has a 95% confidence interval. Which of the following would produce a confidence interval with a smaller margin of error than its 95% confidence interval? So to have, what, a 99% confidence interval, you would need more in the sample, right? Because the more you have, then the more precise you get.
Yeah, that's what I thought.
So A, B, C, D. That'd be D.
What is it? The central limit theorem?
Yes. So
The
the more
larger
numbers you have in your sample, the more accurate and confident you become.
Yeah.
And then what was the law of large numbers again?
That one is, oh, I just blanked on it.
The law of large numbers, I don't remember.
I'd know it if I saw it.
It's the shape. This one is the accuracy, but then the law of large numbers is the shape. It becomes more normally distributed, right?
Yeah, it has more
Okay.
to do with distribution.
Yeah. Okay, so a factory makes propeller drive shafts for ships. The quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory. Okay, so this question is asking for the margin of error for a 95% confidence interval. And then the lower bound and upper bound. I got number 6. That one I just put because where is it? It's that little chart. So for a 95% interval, the z-score is 196, or not 196, 1.96.
Yeah.
And then you multiply that by the standard deviation divided by the square root of n, which is 2. So that comes out to 2 divided by 2 is 1. So it's 1.96, right?
Mm-hmm.
So then for the lower bound and upper bound.
Well, it would be 1.96 plus 1,000.
Right.
Okay, sorry.
For the lower, yeah, oh, I subtracted 2. Okay. Everybody got that? Everybody on the same page? Okay. Number 9, to assess the accuracy of a laboratory scale. Standard, okay, so for number 7, it would be 1,000 minus 1.96. Number 8 would be 1,000 plus 1.96, right?
Wait, so on number 6,
Uh-huh.
wait, how do you find that?
For number 6?
Yeah.
So we're finding the margin of error, which is z times the standard deviation over the square root of n.
Oh, okay.
So for a 95%, here, let me put it up here. For a 90, is that it? So that thing there where it shows you the different, that thing,
Mm-hmm.
I put the 1.96 for the 95% confidence interval.
Okay.
And then, so you're multiplying 1.96 times the standard deviation over the square root of n. So the standard deviation is 2 millimeters over the square root of 4, because she sampled 4.
Just 2.
Oh, okay.
Does that make sense?
Yes, so it's 1.96.
Yes.
Okay, sorry, I was confused.
No, you're fine. For 7 and 8, though, I got those wrong, but I added and subtracted the 2 millimeters. I was supposed to add and subtract the 1.96. Is that right?
Yeah.
Okay. Okay, number 9. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times. I didn't save my notes from where I figured this out. Oh wait, I got it wrong anyways, so I don't know. I didn't do that one right. Okay, so a weight, 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with an unknown mean and standard deviation of 0.01 grams. How large should n be so that a 95% confidence interval for the mean has a margin of error of plus or minus 0.0001?
Oh, I know how to do this one.
Do you? Let's hear it.
Yeah, so you do n equals the z-score times the standard deviation divided by the margin of error, and then all of that is squared.
Yep.
All of that is squared. Oh, that's what I didn't do. Okay. I didn't square it. What did you get? What did you get for that one? For 9?
Oh, what did I get? I got 38,416.
Okay. For number 9?
Mm-hmm.
Okay. All right, I'll have to go back and write down that formula. C times standard deviation divided by margin of error and then squared. Okay. Number 10, the mean area of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses for the mean are, I put D, because they think that the mean is less than 1,250.
Yep. That looks right.
Number 11, in a statistical test of hypotheses, we say we reject the null hypothesis with a level of significance, if P is less than the level of
So
significance,
B.
that's B. Mm-hmm.
Agreed.
Everybody agree?
Yep.
Okay, number 12, a group of students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect the GPAs from an anonymous random sample of 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question? I put yes, because those requirements, let's see, I put C.
Yeah.
Where is it? You have that too?
Yeah.
That's what I would think.
Because it fulfills the requirements.
Because they're normally distributed and their variances are nearly equal. So
Right.
that's the 2 requirements.
All right. Number 13, a medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has, I put A. Does anyone have any input?
Yeah, it's either A or D, but I can't remember exactly which what.
So I just looked at my little chart from my notes.
I have
Or
a
if-
hard time keeping them separate.
If you reject the null hypothesis, but then the null hypothesis is true, then it's a type 1 error.
Yeah.
Here, do you remember these notes?
Type 2.
That little,
Type 2 is you retain the false null. So yeah, it'd be type 1.
yeah.
Yep.
Okay. Number 14, the level of significance A is made very small. thereby making it the probability of committing a type 1 error very small. What happens to the probability of committing a type 2 error? It's going to go up as they go like this, like a scale. So as one goes up, the other one goes down. As one goes down, the other one goes up. So A. Does everybody agree on that one?
Mhm.
Or do you have other
Mhm.
ideas? No?
Mhm.
Okay. Sorry, I feel like I'm flying through this.
It's okay.
No, that's all right. I'm just.
Okay, question 50.
I haven't done them.
What's that? The nicotine content in cigarettes of a certain brand is normally distributed with a mean and in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give the sample mean of 1.53. Is the evidence that the mean nicotine content is actually higher than advertised? To answer this, okay. Wait a minute, what?
Let's see. Standard deviation.
Mean nicotine content is actually higher than advertised.
I thought it would be C because it's such a small difference.
I'm in my class right now. I need you to go. I want you to stay in there for just 5 more minutes. You can look at a book, and then we're going to get ready to go. I put D, and I don't know why. I remember being really confident, and now I don't know why.
Is there a formula you use? Do you remember?
I don't think so. Hold on. Standard deviation. I don't remember if I used a formula or what I did. I got it right, though, when I submitted it, but I don't know how to explain it. I can't right now, honey. I don't know. I don't know how I did that.
It seems like you would need to find the p-score somehow.
Is that what it is? I don't know how I did that. Oh, wait a minute. I don't know where my notes are now. My scribble pad. Yeah, because it's the x, what's the thing? X with the bar over it, minus the mean, right?
Okay.
Over, what was it? What was that? I'm remembering that equation. Let's see, that's out. Do you remember that at all? The
I think I know what you're talking about.
let's see my notes.
Is it the mean? No, the x bar minus the mean over standard deviation divided by
Mom?
n?
By the square root of n.
Hi.
Okay. Annie, go ahead and
Sika.
I think that's it. So it'd be 1.53
Sika.
minus, what was the mean?
Hello.
I think it was 1.5.
I need to look. I'm in class right now. I need you to go quietly. Read a book. I'll play with your daughters for a few minutes, okay?
Should we play with
Sorry, guys.
Well, since we know the standard deviation, I think it's just the x bar minus the mean over the standard deviation. And then that gives you a z-score, and then you use the applet to find the p-score.
Oh, yeah. I think that's right.
your headphones?
Hang on. You guys can carry on. I'll be right back.
Okay.
Okay, I'm back. Okay. Number 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. That would be independent samples. B, right?
Mhm.
17, an educator is interested in academic achievement by males and females in similar academic support systems. She decides to use brothers and sisters. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. I put D, dependent sampling, because she's comparing siblings. So if you have a brother, you have to have a sister.
Yeah.
Okay, D. All right. Number 18, I'm not sure about. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The measurements are recorded. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. And I'm not sure about this one. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation?
Can't remember what I put. Mhm. Soil sample.
I built a thing and it looked like there was a standard deviation. So I put C, but I got it wrong.
Okay. I put confidence interval for the mean when sigma is unknown. Or its standard deviation. Because it doesn't say the standard deviation in the problem anywhere.
Okay. So you put A?
Yeah. Does that make sense though? The reason why?
Well, I know it doesn't mention it in the verbiage, but does it show it on the document?
Oh, no, it doesn't.
It doesn't? I must have done it wrong because I got
Well,
one.
you probably got it for your sample, not the actual, like all of the dissolved organic carbon. You didn't get the standard deviation for that. You just got it for the sample. So the
Oh.
actual standard deviation is unknown.
Oh, okay. For the
that
total
make sense?
population.
Yeah.
Okay. So I was looking at it for the sample. Gotcha. Okay, that makes
Because
sense now.
I don't think there is a way to know the actual standard deviation for all of them in the entire world.
Right, right. Yeah, that makes sense now. Thanks.
That's kind of how I saw it anyways.
Okay. Can you guys hear that? I've got jets flying now. Sorry. I don't know if you can hear that in the background. Okay, which of the following is the 95% confidence interval for this analysis? I built the, what is it? The thing in SPSS. It's okay. And so I got for the margin of error in the 95% confidence interval. Yeah, that's great. Margin of error is 2.025. And that was just right off the test, the study, number 20, input the lower bound, 11.168. Anybody else get those?
That's what I got too.
Good. Upper bound, 15.217.
Mhm.
Okay, and then excellent. Okay, so random sample of Hummers for sale in Los Angeles and New York. The data are recorded in that file. We want to know if there's a difference in the mean listing prices between Hummers for sale in Los Angeles, Group 1, and Hummers for sale in New York, Group 2. When I built my thing, it didn't work. Okay, so 95% confidence interval for the true mean difference, for the true difference of mean listing prices between the two cities. For number 22, I put C. Of the 4 types of confidence intervals, which one is appropriate for this situation? Confidence interval for the difference of means using independent samples. Everybody got that?
That's what I thought.
Yeah, me too.
And then,
Is
like
there
I said, when I built my thing, it didn't work. Like when I was trying to identify the different groups, it gave me this announcement on there, and it didn't work for me. So I don't know if anybody else has any input for numbers 23 and 24.
Did you do the automatic recode?
Yes. Let's see, how did I do this? Okay. These Hummers, I'm reopening this thing now. Okay, here it is. So transform, automatic recode, and we're testing the mean and price, right?
Mm-hmm.
So price is the variable. And then you give it a new name. And then hit OK.
Mm-hmm.
And then you go to Analyze and Compare Means. Maybe I'm doing this part wrong. It's independent samples, right?
Turn on a movie.
Yes. Independent.
Independent samples t-test. In a few minutes, use your scratch paper for a few minutes, please, okay?
What?
Grab that. You can play with that for a few minutes. Right here, Zoe. Okay, so the test variable, right there. The test variable is going to be, see, and this is where I always get them backwards. Okay, the test variable I'm saying is the, go ahead. Well, the grouping variable is going to be the thing I just created, right? The price compare. The grouping variable is going to be what I just created, right?
Think-
And the test variable is going to be city. Would it be city, or is it the other way around? No.
Do you know, Sam?
I'm trying to build it real fast.
Okay.
When I go in, did you make it, or the groups, the cities?
Yeah.
So Los Angeles is Group 1 and New York is Group 2?
Yes, I did.
Okay, that's
where
I'm at so far.
But honestly, I think now I'm looking at it, I think under test variable, I just put the price one instead of the price of the automatic recode thing that I built. So let me see if,
I'm trying to get it.
what they say group 1 is which one? LA or?
Yeah, that's what I was.
Group 1 is LA. There you go, LA. Group 2 is New York. Okay, oh, wait a minute. I think, yeah, it didn't do it again. It says the group subcommand specifies an unknown variable for a long string variable. This subcommand must specify either a numeric value or a short string variable. So it's not building it for me.
Mommy found the set.
Yeah, I might have to go look at exactly how to do them.
Okay. Well, I'm kind of stumped on that one, so I don't know what to say for questions 23 and 24 because I didn't find. And I actually have to sign out. It's 40 after. I'm sorry, guys. Do you want to keep going without me?
That's all right. I probably have to go too.
Okay.
I'm supposed to be somewhere at 2, and I still got to get ready. So
Okay. So are we supposed to do a group meeting on Thursday? It doesn't look like it. Unless you guys want to meet together and kind of go over anything.
isn't today Thursday?
Oh my goodness, yes, today's Thursday. You guys, I am so sorry. Our life is so
Alright.
hectic. And with my dad, and he's home now, and I'm a caregiver, and I'm all over the place. I'm really sorry. I'm basically juggling my life right now. Okay, sorry. Yes, today's Thursday. Duh. Okay.
That's all right. She did send a message out this last couple days. We got to start thinking of oh, I forget the word. I just blanked.
Oh, our project.
A study.
We have to start thinking of a run,
Okay.
pretty much. So I just say, just think of some stuff because I don't know. Just
Okay.
be thinking of things you could try. I don't know. I don't really know how it's gonna work, but
We can do this. We can do this. Okay.
I think she said next week is the first thing we have to submit for it, or just like or something. I'm not sure, but just
All right.
letting you know that that was out there.
Yes, I did see that. We got this.
Okay.
Well, we'll be in
Yeah.
touch with email, and we'll
Okay.
be in touch.
Guess we'll see you next week.
All right. Good luck on the test, everyone.
Good luck. Bye.
Bye.